Hello, this is Natalia, and I'm going to be explaining how a DC motor works. So, this is a picture of the motor that my partner and I created in class using the materials provided. We used a 1.5 volt battery, a pack of 20 gauge red coil, wrapped around a cylindrical object 15 times, and then you leave about 2 inches of space on either side, and you strip it using sandpaper to provide a better connection. 2 paper clips are attached on the sides of the battery, which was a problem that my partner and I found because it didn't provide a good enough connection for the battery to make the motor spin. Next time I would put it somewhere else. And then we have 2 magnets that we were playing around with, trying to see which one would work better. We had a neodymium magnet and a bar magnet, and unfortunately neither of them made the motor function correctly. And the paper clips are propped up to hold the rotor in place. So how does it work? Motors convert electrical energy, which is coming from the battery in this case, into mechanical energy, which causes the rotation in theory. When a current-carrying wire is placed in a region where a magnetic field is present, the wire will experience a force. Well, now the size of the force, which determines how fast the motor will spin, is dependent on the amount of current in the wire, the length of the wire, and the strength of the magnetic field. And an equation to represent this is force equals current times wire length times magnetic field. So how does it work? Continued. The direction of the force, which determines which direction the motor spins, is dependent on the direction of the current in the wire and the direction of the magnetic field. And we can figure out these 2 things by using the right-hand rule, which we've learned previously in class. The thumb represents the direction of the current. The way your fingers are facing are the direction of the magnetic field, and your palm is the direction of the force, which is new. The bar magnet, or the neodymium magnet, whichever, provides the magnetic field, and with the magnet in position, the magnetic field is directed vertically out of or into the magnet, depending on which side the magnet is exposed. And when the rotor sits in the paperclip supports, so that the plane of the loop is oriented vertically, the top and the bottom sections of the loop act as current-carrying wires in the region of the magnetic field. And that's how a DC motor works. Thanks for listening.